Welcome, ladies and gentlemen, to another tutorial about AI UI. This time we will talk about a very popular tutorial, a dataset called iris dataset. It's based on flower length and width. Okay, so let's create this project out of nothing. Let's call it iris, create it, and jump in. I've already loaded this dataset before. So what do we have? We got 5 columns. 4 of them are input features, and the 5th column is the variety. Let's have a look at how many varieties we can find and how the data is distributed. So, okay, nice. The variety is evenly distributed. That means we got 50 examples for every variety. No need to resample anything later on. Okay, what do we need? We need one-hot encoding because the variety column is a string column. The neural network cannot deal with these strings. We have to transform it in a way the neural network can work with, and that's normally a number or anything like this. So we will transform it with one-hot encoding. That means an array is defining what kind of category it is. 100 stands for setosa, 010 for versicolor, and 001 for virginica. Okay, so what now? Normally I would now choose min-max scalar. That's just experience, but let's have a look at the value distribution first. Before we use this, I want to see how the values are distributed. The input feature values. So let's have a look. Okay, we'll make it bigger. So what you see here is the range of the input feature values. You see they reach from 0 to 8, but they are different. Okay, in my experience, it often helps to create better accuracies, especially for classification tasks, if you scale the input features before you use it. Okay, that was failed because nothing should be scaled, or everything. Well, everything is scaled, but I don't want one-hot encoded values scaled. So I just pick out the input features, and as you can see, these are scaled in between minimum, maximum, and 0 and 1. So if I now take this box plot again to plot it, then we should see that all the variables, the input features, are in the same range in between 0 and 1. Okay, that means their influence on the neural network is nearly the same. Okay, we don't want to prefer any feature over another. Normally, there might be cases where you might need this, but not in this case. So let's go on. What do we need further? No resampling, time sequence. We need a train validation split, or test train validation test split. Okay, so we will split it in between 70%, 20%, and 10%. We shuffle it, and we want we want it stratified. Okay, so that means all three varieties are in each data set evenly distributed. Let's go. Okay, that's it. So, but well, I would like to have here a value, okay, that is divisible by 3 in a better way. Let's have a look. Because I want later on the same amount of every class predicted. So I have to check for the right amount. Okay, 21, that means 7 of every variety is in the test data set based. So you will understand what I mean later on. Okay, now what do we need? Training node. But first let's talk about the architecture. I will switch to it. Save. Okay, architecture, I already built one. We got an input layer, we get 4 input features. Then I just took some dense layers with ReLU activation function, and the last one had 3 units with a softmax activation function. Okay, back to our project. Let's take the architecture node and start with our training. Okay, let's give it a name, Iris 1. Our targets are these 3. Our batch size will be, say, 51. Shuffle true, or we can take the full batch size, the training node, and our metrics. Take this and just try 2000 epochs. We won't need this, but okay. Proceed. Oh, I must have forgotten some. Yeah, I have forgotten to choose an architecture. So now we can start. Let's go. It's very fast. As you can see, so incredibly fast that the plot isn't as fast as the training process itself. Okay, we are done. Now we want to know how good our model is. So we have to make a prediction. We take a prediction node and a data set, test data set. And then we proceed. Prediction is done. And because we got a classification task, we want to see what's happening in a confusion matrix. Let's have a look. Okay. And as you can see, well, our model is not good trained right now. This is the way that should be perfectly predicted, but in this category we got some problems. So let's try again to train a little bit. What about 3000 epochs and do it again from the beginning and see what's happening then. Maybe the training time was not long enough, or yeah, we got another problem. Maybe the neural network is not capable of yeah, getting the work done it should because of the architecture or the activation functions and so on, but we will see. Okay, let's give it some time. Okay, done. Now we repredict again and proceed with this prediction. And as you can see, now we know what was happening. We just had not enough training time. Okay, now we just trained 1000 epochs longer. The loss was coming down for validation loss and also the training loss, and that led to better results. So, and now we can also do some model interpretation with SHAP. We take the same data set and the same model, for sure, and we will predict the SHAP values. For example, a SHAP summary plot. We will see on which features the model relies most on. So now you can see petal width is the most interesting feature. What this plot is showing you is all of your 4 input features and what's the most important. Okay, it's petal width. The next one is sepal width, and then petal length and sepal length. Okay, and you see these features are most important for the 2 classes variety setosa and variety versicolor. Okay, so what's very good is you can just train your model even if you have chosen not all the right features. Then you can also train your model, have a look at the SHAP values, and if you find features not really in use of the neural network, or better to say features that the neural network not needs to predict what you want to predict, then you can go back, kick it out, and retrain again. And if you want to retrain anything on a new data set, maybe you got some new values inside here, and you reload a new data set, you can just go on and click on execute all nodes, and everything is going on by itself. It will process every node, every step we have taken right now until it reached the end. Okay? You don't have to worry about anything. It will just do what you have already done, but with new data. Thank you for your attention and have a nice day.